Hi, welcome to Biology Videos at TDA. We're doing 13.8 reflexes in this lesson. It's going to be a relatively short video with some activities attached to it. Our objectives is to understand why we have these reflex actions and then the value of them, and then we need to know about some different reflex actions and then be able to apply them to an exam situation. Okay, so to start us off, just a recap from GCSE really around the overall reflex action, the reflex arc. So this is an example with a heat stimulus. So we've got a stimulus from the candle, which is heat, which is going to be detected by the thermoreceptors in the skin. That's going to then send an action potential, an impulse down the sensory neuron that's then going to end up at the spinal cord. That will then pass on via a synapse to the relay neuron, and then from there it will move to the motor neuron and then to the muscle, which is the effector. And in this case, this is the biceps brachii muscle, and that's going to cause the arm to flex, so to move away from the heat source. So this is a really common example of a reflex action, and you need to be able to describe all these different steps that are from GCSE. So a reminder, why do we have reflex actions? Well, first of all, they're quicker, and the relay neuron is found within the spinal cord, unless it's a cranial response, and we'll look at those later on. And this is just another image of it. So we've got the stimulus that causes detection by the receptor, action potential, goes down the sensory neuron. We know it's a sensory neuron because the body's away from the axon. Relay, synapse, motor, and then effector. Okay, so the example I want to show you is knee-jerk reflex, which is when we extend the foot out forwards due to pressure being felt on the patellar tendon. So within the kneecap itself, we have this tendon that goes with, which has the kneecap itself embedded in there, and there are stretch receptors here that detect how far bent the foot and the leg is. So if we have our foot pulled backwards, there's going to be more signals sent from the stretch receptors to then cause us to extend our foot out. So the way this one works is, if we apply force and pressure to this tendon, because there's stretch receptors in there, that's going to cause the tendon to stretch like that. I can see if I can rub that bit out. And I know this is an over-exaggeration, but the idea is, if you apply pressure with a hammer to this tendon, the body is going to think then that the foot, I can do a bit, it's a terrible drawing of the foot, but you see what I mean. The idea is that the foot is further back. There you go, that's what I meant. The idea is the foot is further back. So that's what the body thinks because we're applying pressure to these stretch receptors. So what happens is, this is detected, this goes down the sensory neurons, this then goes to a relay neuron in the reflex action, and then this causes the quadricep muscles, so they're the extensor muscles, they're a group of muscles, quad meaning 4 muscles, within the thigh that causes our foot then to contract, and we're going to straighten, so we're going to extend our foot at the knee joint. So the idea of this is trying to protect our kneecap itself and our leg from being bent too far backwards, and we can recreate these reflexes with a hammer. So you can have a go at this with someone around your house. Don't start hitting your younger brother or sister or older with a hammer, saying it's for science. What I want you to do is get yourself set up on the kitchen worktop or something safe, and then see if someone in your family can have a go. And you don't want to hit the kneecap, that would be really painful. You want to hit just below, and if you feel your kneecap now, just below it there's like a sort of little indent, and you can press into there. Now if you do it yourself, normally it doesn't work so well, so you need to get someone else to do it for you. But you can have a go at this, and then you'll hopefully learn about this reflex arc itself. Okay, the other one I want you to look at is a cranial consensus reflex of the eye. So those two words, cranial, meaning within the cranium, within the brain. So this is a reflex action that doesn't use the spinal cord, because it wouldn't make sense. It wouldn't be quicker if we sent the signal down the spinal cord. And then consensual, because both eyes are going to do it at the same time. So this is the blinking reflex, which is a really common one. So again, why do we have this reflex? We have it to protect the eye itself. And then how does it work? Well, some kind of stimulus, in this case this is touch, is going to be on the cornea, and this is trying to protect the cornea lens and the rest of the back of the eye. It could be bright light, it could be a loud sound between 40 and 60 decibels, whatever the stimulus might be, or it might be a little blow of air. That's going to cause then an action potential to go down the sensory neurons. That's going to then be relayed within the brain itself, then that's going to come back and that's going to cause contraction of the eyelids. It's going to close the eye to protect it. Now, because of the position of where the relay is within the brain, this can be used as a tool to detect whether a person is lower brainstem dead or not. So a person may be unconscious in a coma, for instance, or it may be a doctor deciding whether a person has died or not. You can stimulate this reflex in some way. You can blow into the eye or touch it however you want, and if there's no response, that could be evidence that a person is lower brainstem dead. But if a person is unconscious and you cause them to blink still, even though they're unconscious, that's an example where they're probably still alive, and that can be used to diagnose people. But the key point is you understand that this is protection of the eye. So, the overall, well, why do we bother with these reflex actions? So, these are kind of key points to note, and they apply to pretty much all reflex actions. The first one is that they're unconscious, so they don't require cognitive load, they don't require you to think about it. And they give these consistent responses, no matter what the situation is, no matter generally how old you are. There's some that we'll look at that change over time. But it allows us to always have a good response. If there's something hot, we're always going to move away, and that's going to increase the survival. Now, our hand ourselves, if we burn our hand, that's probably not going to lead to death, but before modern medicine, that could lead to infection, or that could lead to damage to the hand that prevents you surviving in a different way. So just be aware of applying that in questions. Most of them, not always, but most of them are present at birth or develop from a young age because we need them to survive. So we're going to look at the Moro reflex in a question. They're very, very fast. It can be a tenth of a second, and how fast it is going to increase the survival chance. If you take too long to blink, if you get some dirt in your eye and you don't clean it out, then that could cause damage to the cornea. And they also help us complete everyday actions without having to think about them, such as maintaining your posture. If you're riding a bike, you don't think, lean left a bit, lean right a bit, your body's doing it all the time. So the key idea here is it's unconscious, so it's involuntary, and they're consistent responses. And because we're sort of high order thinking mammals, this allows less cognition, less thinking about them. So for instance, you don't have to think about your breathing all of the time, or sitting up all of the time. If you did, you wouldn't be able to consciously think about more complex things, such as how am I going to get that food down from the tree if you're a hunter-gatherer. Okay, so a couple of questions. There's not many. So this was a question on I believe the unified paper, so the final paper a couple of years ago. So, reflex actions are rapid responses, protect the body from harm. The Moro reflex is found in babies up to 5 months of age and occurs when a baby feels its head is suddenly no longer supported. So, these are the responses. The baby spreads out his arms and then brings them together rapidly, key point, and the baby cries. Suggest how the Moro reflex prevents them from harm. Okay, pause the video, have a go. And then the final question, it gradually disappears and usually stops completely after babies reach 9 months and other reflexes develop. Describe a reflex response a 3-year-old child would make from an object moving towards their eyes. There you go, and the advantage of that. Okay, have a go. Okay, so for question 1, we were looking at the baby. So if we look at the first point again, spreads their arms out, brings them together rapidly. Easily missed here, so read through this comment, pause the video and read through it if you don't understand. But the idea here is the bringing the arms together quickly allows you to grab on. Babies have quite a strong grip, surprisingly, and they can grab hold of things and at least slow the fall, perhaps, if they were falling. So some kind of description is allows them to hold on, or try to at least hold on to something. And secondly, the crying that makes sense. It's going to bring attention from the mother or the father or whoever to try and then help the baby. The second question, so why is this reflex response going to be useful? Advantage of this response for the eye blink reflex. So we're going to have closing of the eyes, explain it, so it's involuntary, and the idea is it's going to prevent damage to the eye. Okay, so that's it in terms of the video. I will share my homework, a caboodle set of questions. They're pretty straightforward, and the mark scheme you can have a go at. And then finally, kind of the last sort of challenge to set you here is see if you can have a go at designing a little reflex experiment with the members of your household. So maybe younger brother, older brother, whoever we live with. You could maybe get them to do this. This is an example of a reflex action, a reflex test, and see how fast your reactions are. And there's lots of other ones. You could use a ruler drop test, however you want. So you could, I'll give some suggestions here. You could get them first thing in the morning and say, do this test. You could then try again at midday, or you could try and do it before or after a cup of coffee, or just before they go to bed. When are they slower? Are they slower first thing in the morning? Are they slower in the evening? However you want. You let me know how you do it, and then the key thing I want from that is how are you controlling that experiment. If you're giving someone a cup of coffee, should you be giving them a glass of water before you give them the coffee? That kind of thing. Let me know how you get on with that. Okay, thanks very much guys. See you next time.